In this video, I'm going to go over a clustering example using a fictional Tesla dealership dataset. Just a few observations here. You can see we have 100 instances and 8 attributes. Okay. So to check more about the data, I'll click on Edit. Again, we can see that, in this hypothetical dealership example here, the dealership here tries to keep track of how many people walk through the dealership and the showroom, right? What kind of cars they look at, how often they make those purchases. Again, the goal here is to mine this data by establishing or finding, relationships or patterns in this data by using clusters to determine different behaviors about our customers here in the case of a Tesla dealership, right? So each row here we can see has zeros and ones, right? So the ones here just refer to did these customers make it to the step of purchasing a vehicle, or did they look at it, right? Zero just means they didn't do any of those steps, right? So I'm going to close this. To perform clustering in WEKA, just click on this tab here, cluster. And a cluster, we're going to click on choose, and we have several clustering algorithms or classifiers. So for now, we're just going to use this for this example. Simple k-means, one of a very widely used clustering technique. Now we want to configure this a little bit. So I'm going to click here. Again, we have various parameters available to us where we can configure different values, right? But for in this example, we are interested in the number of clusters. So let's change this value to 5. So it can have 5 clusters. Again, we can see by default, clustering just uses different distance metrics. By default, we're using Euclidean distance, which is simply the square differences of between two distances in a straight line. Okay, click on OK. We'll leave this as training set, and then we click on Start. In the output results, we can see different patterns are emerging, right? We have cluster 0 all the way to 4. But now the real question here is how do we interpret these results, right? So again, we can see here we have zeros and 1. 0 here meaning that everyone in this cluster has a value of 0 for this attribute. Okay. At the same time, we can see 1 just means the average value for everyone in that cluster. Let's start by looking at cluster 0 here. Let's label this group of people dreamers, right? Because they appear to just wander around or walk around the dealership looking at vehicles parked outside on the lots, but they never come to completion. They never finalize with the purchase, right? So that's what we can tell about this cluster, right? And then cluster 1 here, things get a bit more interesting. Let's call these people, Model S, right? You can see here, they know what they want. They just walk right in and visit the Model S, right? Lot or showroom or section, totally ignoring Model Y, right? And also a little bit percentage here, right? But again here they continue with financing, but most of them just don't end up with the purchase. It's quite a 52% here end up with the purchase, right? It's not a high number, but again, there's potential problems here that can provide room for improvement for this kind of dealership. Maybe, send this group of people to salespeople in Model S, to drive up, drive up those numbers, right? Then we go to cluster 2. We can already see that this is a small group. It's very hard to tell. Statistically, it's very irrelevant. Again, we can't draw any good conclusions, based on this relationship or patterns of behaviors, right? So one thing to keep in mind is that sometimes this do happen, right? This could be indicative of, the number of clusters. So for example, here, if you have very few clusters, you might end up, having those, different issues. So again, that's one of the limitations of using clustering, getting that optimal number that's going to reveal those insights or patterns in your data. And then group number 3 here, you can see these are what I would refer to as the Tesla lovers, right? The Tesla babies, right? You see, they end up actually purchasing a car, all right? At the same time, they end up financing that. It's 100%, okay? So again, they appear to walk around a lot looking at cars. Then they turn into computer search, very high rate here. And this computer search was saying it's available at the dealership. Ultimately, they end up buying Model S and Model Y, right? But never Model 3. These are very interesting numbers and behavior. So what this can tell us is that, what if the dealership, may perhaps consider making the search in their computers more prominent around the lots, right? Or maybe put outdoor computers for people to start using. All these are different things that they can put in to improve or just to make Model S here and Model Y more prominent and drive those sales up, right? Lastly, here you can see every time this customer walks in, right, they have already made up their mind to purchase a vehicle, right? And most times they end up qualifying for financing, right, and completes that purchase. That's some of the insights we can glean out of this. And then lastly here, cluster 4, we can probably refer to this group of people as first-time buyers, right? Those who are just starting out with Tesla. Okay, they always most times just look around and check for Model 3, 100%, all right? And this could be, one of the reasons, because Tesla Model 3 is quite affordable. It's a cheaper model, less expensive than, let's say, Model S. And that's why no one in this group even gives it a look, right? It's totally zero, right? Because it's a more expensive model, right? Another thing we can derive here, we can see is that 50% of these guys, they end up financing, 30, and then 32% ultimately, seals the deal for this transaction. Okay, perhaps as a dealership, they can draw a conclusion that these customers are Tesla, first-time Tesla buyers, right? And they know exactly what they want if these numbers are anything to go by, right? Because this is an entry model. So, okay, so what the dealership could possibly do, probably increase the sales here to this group by probably, reducing or minimizing some of the regulation or restrictions that associated with financing to drive up this number, okay? And probably even put some discounts on Model 3 to drive up those sales numbers, okay? And that's how to integrate, a clustering. So it just takes a bit of practice to get, to understand what's going on. Now, another interesting way to examine the data is to visually inspect that. So to do that, right-click in the result window, and we can, visualize the cluster assignment. It will pop up this window like this, right? So let me just maximize this here. So the other thing, what we can do, this is called cluster assignments, right? So the first thing we want to do here, we can change the x-axis over here. Let's change this x-axis to Model S, for example, right? And then the y-axis here, we can change this. Actually, we change it to purchase, right? And then we can just leave everything there. And then we want to change this, the jitter. The jitter just makes things artificially more visible. We're adding more points to our cluster. So just take it all the way here. All right. And then now you can already see some visuals that matches some different things here. So for example, let's look at where X and Y meet, right? Where X is 1 and Y is 1. So look at here. You can see the cluster here is 3, right? And the cluster here is 1. So if we go back to our output here, we can see that majority kind of just agrees, these are actually Model S. If you look at cluster 3 here, these are the guys who buy Model S, right? Again, if you look at, so if we go and look at 3 and 1, right? You can see. So actually we can make a conclusion here. So these are the customers who buy Model S. So actually the cluster assignment agrees in terms of visualization. And then if we look at X equals to 0 and Y equals to 0, right? We can see this cluster 0 and cluster 4 based on the colors here, right? Again, the question is, does it match, our output here? Yes, it does, right? Then also we can see clusters 1 and 3 here. Again, these are the ones who, individuals who actually we've already seen the buy Model S, right? And 0 here, it appears they don't buy anything, right? They really don't buy anything given the color assignment here. Okay. And cluster 4 here, if you look at cluster 4 here, most times based on our output, these are people who are just looking around, wandering around, at Model 3. If you look at Model 3 here, right? So these were individuals who are just walking around, looking at Model 3, hence the cluster 0 here. Okay. All right. So in conclusion here, the clustering algorithm just takes some data, okay, and groups them into categories or clusters. Okay. So we could perhaps make some conclusion based on these patterns or trends that we see within these groups, right? Again, another thing here to keep in mind is that clustering is different from other supervised, learning techniques like classification and regression, because we are not producing any output, as we've already seen in the previous video, right? And instead, we are trying to observe the output and attempt to, kind of derive some conclusions, right? So in this regard, we can actually conclude that it's very difficult, especially when you're using clustering model to correctly make these observations, right? So it's kind of subjective, but again, if you do it right, you're able to, generate some interesting or gain some interesting information from your results, okay? Things that would not have been otherwise possible, right, by other models. And that concludes clustering in WEKA.